All right, and we're going to continue with our work with solving equations. And once again, just like we've done in our prior lessons, we're going to start with that connection to graphing and systems of equations and what we are really looking for, all right, when we solve an equation. All right, so once again, we're still sticking with our standard 10 here, topics 1 to 4. I can solve linear, absolute value, quadratic, and exponential equations. All right, so just like we've done in most of our lessons here, I'm going to have you do the opener here, but I'm only going to have you do parts A, B, and C. So once again, I'll do the exponential with you because we didn't quite talk about how to graph one in this form. All right, but you should be able to do parts A, B, and C. All right, so what I'd like you to do right now is go ahead, pause the video, do parts A, B, and C, flip it back on, and we'll see how you did. All right, so let's take a look. All right, so on parts A and B, right? So once again, we talked about this, right? So work with identifying your function first, whether you're graphing, solving, whatever, right? So we have a linear function here. All right, my starting point is negative 2, 0. I have a slope of 2 over 1. Y equals 8 is a horizontal line. There you go. So you can see that our solution is 2, 8. Okay, now part B. All right, now it's an absolute value equation, right? Okay, I see those absolute value bars. That means my vertex is negative 2, 0. We know it's going to open up because it's a positive A value, so up 2 to the right one, up 2 to the left one, and we continue that. And then once again, we get to that horizontal line, y equals 8 up here, and you can see that we get 2 points of intersection, negative 6, 8 and 2, 8. Okay, now let's look at, all right, I'm going to just kind of zoom over here so we can look just at this quadratic, which is what you guys did. Now, once again, we know it's a quadratic, right? We can see the power of 2 here. My vertex is negative 2, 0, and then remember it's A, 3A. So my A value is 2, so up 2 to the right one, up 2 to the left one. My 3A value would be 6, so I'm going to go up 6 to the right one, up 6 to the left one, and once again, we get two solutions, right? Negative 4, 8, 0, 8. Okay, so hopefully you did well on that. So once again, this is reviewing graphing for you, all right, which is good. It'll keep that fresh, but also making a connection. Like when we solve an equation, we're looking for these x values, right? Where do those functions intersect? Now, let's take a look at, all right, part D together here. Now, I'm going to start with y equals 8, because that's the same as all the three before. So that's that horizontal line right here. So I'm going to draw that in. Y equals 8. All right, just like that. All right, now, when we look at this, this is still our exponential, right? The k value doesn't change, so that's still going to be our floor. In this case, our floor is 0. So, doom, doom, doom. All right. Now, all I'm going to do is start plugging in values here. All right, so I'm going to create just a little bit of a table here. All right, so a little xy table. I'm going to start with negative 1. So if I plug negative 1 in here, I get negative 1 plus 2, which is 1. 2 to the first power is 2. 2 times 2 is 4. So at negative 1, I get to 4 right here. All right, so negative 1, I get 4. All right, and then I'm going to plug in 0. So when I plug in 0 here, I get 0 plus 2, which is 2. So then 2 squared is 4. 4 times 2 is 8. So I get 0, 8 right there. All right, and maybe I should plug in negative 2 here. Just give me a third point here. So let's do negative 2. I should have maybe started with negative 2. But negative 2 plus 2 is 0. 2 to the 0 power, and remember, anything to the 0 power is 1. So this would be 2 to the 0 power, which is 1. 1 times 2 is 2. So this would be 2. All right. And so we know it's going to, the tail is going to follow that floor, the asymptote, and it's going to come up. And we can see that we get this, hopefully you can draw a little bit better curve than I did there, get that point of intersection at 0, 8. All right. Okay, so 0, 8 right there. Okay. All right. So now, how does this all tie into solving? All right. So now, what today's lesson is going to focus on, all right, is basically how do we work with grouping symbols when we have something inside the grouping symbols? All right, so once again, when we solve an equation, we're saying, where is this function equal to this function? All right. Okay, now, once again, we look at what kind of problem is this. This is a multiplication problem. This is 2 times something is 8, right? So 2 times what is 8? And that would be 4. So whatever is behind my hand has to be 4. So that means x plus 2 has to be 4. Now, we can get this equal to 0, or if you know the math fact, we can go right to that, right? So what plus 2 is 4? That would be 2, right? Or if you want to get it equal to 0, we could subtract 4 from both sides, right? X minus 2 is equal to 0. And we could use the 0 property. So 2 minus 2 is 0. Okay, now, this is very important. All right, so we set this up the same way, right? So where is this absolute value equation equal to 8? Now, once again, notice this is a multiplication problem. It's the same multiplication problem we have right here, right? 2 times what is 8? And the answer is still going to be 4. But notice what's different is what is equal to 4, because now the absolute value of x plus 2 is what's equal to 4. Now, when we have something in our grouping symbols, all right, we have to ask ourselves, okay, so the absolute value of what is 4? And we know that there are two answers to that, right? We get 4 and negative 4, right? We have two numbers that are a distance of 0 or 4 from 0. So that means x plus 2 could be negative 4. That means x plus 2 could be positive 4. All right. Now, from our graph, we should know, okay, this makes sense, right? We had 2 points of intersection. All right, and then once again, if we don't know the math fact, we can get it equal to 0. So what plus 2 is negative 4? I don't know. So let's add 4 to both sides, get it equal to 0, right? X plus 6 is equal to 0. All right. Oh, so what plus 6 is 0? Negative 6, right? We know they have to be opposites. Now, x plus 2 is equal to 4. What plus 2 is 4? That would just be 2, right? All right, and then notice if we go back to our graph, right? Where do these two functions intersect? Negative 6 and 2, 8. And then we can see that that's where the negative 6 and the 2 come from, right? So we're solving for that value, right? Where do they intersect? They intersect at negative 6 and at 2, all right? Okay, now moving on to part C here. So once again, where is this quadratic equal to 8? And once again, it's the same problem, right? 2 times what is 8? Okay, it's still going to be 4. But what's changing is what is equal to 4. This time, x plus 2 squared is equal to 4. All right, and so now we have to ask ourselves, right, what squared is 4? And once again, there are two answers here. 2 times 2 is 4. Negative 2 times negative 2 is 4. So whatever's inside, right, behind my hand can be 2 or negative 2. So that means x plus 2 could be negative 2. X plus 2 could be positive 2. Now, once again, if you don't know the math fact, get it equal to 0, right? So I can add 2, add 2. X plus 4 is equal to 0. What plus 4 is 0? Negative 4. So there's our answer, right? X plus 2 is equal to 0. What plus 2 is equal to 2? 0. All right, so x is equal to 0. And so once again, if I bring this over here, right, where do those two things intersect at? Negative 8 and 0. Or excuse me, negative 4 and 0 there. All right, and that's where those answers are coming from. Now, once again, similar fashion here, right? Where is this exponential equal to 8? And once again, it's going to be the same multiplication problem, right? 2 times what is 8? And then once again, the answer is 4, right? So 2 to the x plus 2 is 4. Now I have to figure out, okay, so 2 to what power is 4, right? So if we start going through this, so 2 to the first power is 2, all right? 2 to the second power is 4. So that means that this has to be 2 to give me 4, right? So x plus 2 has to be 2, all right? Because it's got to be 2 squared is 4. Now, once again, x plus 2 is equal to 2. So what plus 2 is 2? And that would be 0. All right, and then once again, if we go back and look here, where do they intersect at? At x equals 0. And that's really what we're doing here. So we're treating all of these things as one entity, right? So whatever's in that grouping symbol, right, we're going to set equal to whether it's a square, right, absolute value to those particular values. All right, so let's do a handful more problems here together. All right, so let me, oh, there, page 34 here. So let's look at this. All right, so once again, and we're once again looking at this, right? So I have 4 times something is 16, right? So 4 times what is 16? 4 times 4. So whatever's behind my hand has to be 4. So x minus 2 has to be 4. Now, once again, if you know the fact, write the answer. So what minus 2 is 4? All right, 6 minus 2 is 4. But if you don't know the answer, you don't know the fact, right, you can always get it equal to 0 and use your 0 property, right? So subtract 4 from both sides. 6 minus 6 is 0. There you go. All right, let's move on to problem 2 here. All right, so once again, 4 times what is 16? 4 times 4 is 16, right? Same multiplication fact. What's changing is what is equal to 4. So this time, the absolute value of x plus 3 is equal to 4. Now, I have more than just x in here. So now I have to ask myself, okay, what has an absolute value of 4? negative 4, and positive 4. So that means x plus 3 could be negative 4. That means x plus 3 could be positive 4. And then once again, if you don't know that math fact, right, we can jump and just get it equal to 0. So I'm going to add 4 to both sides. All right, so x plus 7 is equal to 0. What plus 7 is 0? Negative 7 plus 7 is 0. Subtract 4, x minus 1 is equal to 0. What minus 1 is 0? 1. All right, so hopefully you're seeing, right, the connections there. So once again, let's go to number 3 here. This is a multiplication problem. 4 times what is 16? All right, 4 times 4 is 16. All right, so this time though, it's going to be 2 minus x squared is equal to 16, or excuse me, is equal to 4. All right, and then now I have to ask myself, okay, so what squared is 4? 2 times 2 is 4. Negative 2 times negative 2 is also 4. All right, so 2 minus x could equal to negative 2. 2 minus x could equal to positive 2. All right, get them equal to 0. Add 2, add 2. 4 minus x is equal to 0. 4 minus what is 0? 4. 4 minus 4 is 0. Minus 2 minus 2. All right, negative x is equal to 0. All right, now remember this is really like negative 1. This is really like negative 1 times x is equal to 0. So negative 1 times what is 0? And that would also be 0. All right, number 4 here. Number 4 here. All right, so once again, 4 times what is 16? All right, 4 times 4 is 16. So 2 to the x minus 3 has to be 4. Now, once again, this is an exponential, right? So if we go through our powers, 2 to the 0 is 1. 2 to the first power is 2. 2 squared is 4, right? So that means that the power here, this has to be 2, right, to make it 4. So that means x minus 3 has to be 2. So I'm going to subtract 2, subtract 2. X minus 5 is equal to 0. What minus 5 is 0? And that would be 5. All right, so let's jump down and do a couple more problems here because I want to show you a couple of division problems. Now, so let's go down, and when we see to number 9 here, when we see this bar, this is division. Okay, this means division. All right, you see this in a fraction, right? So, but that really means division as well. So now this is a division problem. So now if I cover this up, this is really saying what divided by 2 is 2. All right, so if I think about what number can I divide by 2 and get 2, that would be 4, right? So 4 divided by 2 is 2. So whatever's behind my hand has to equal to 4. So if I take that away, that means x plus 7 has to equal to 4. So subtract 4 and subtract 4 to get this equal to 0. X plus 3 is equal to 0. What plus 3 is 0? That has to be negative 3. All right. So we treat it the same way. It's just a, all right, fact, right? So what's the answer to that fact? So let's go to number 10 here. All right, so then if I look at this one, something divided by 3 is negative 2. Okay, so what divided by 3 is negative 2? That would be negative 6, right? Negative 6 divided by 3 is negative 2. So that means whatever's behind my hand has to be negative 6. So that means the absolute value of 5x has to be equal to negative 6. Now, here's what we know. An absolute value can never equal to a negative number, right? It can only equal to a positive number. So what this means is this is a no solution problem. All right, let's get through 11 and 12 here, and then that'll wrap up our video. So when I look at 11, all right, what number divided by 8 is 2? 16 divided by 8 is 2. So whatever's behind my hand has to equal to 16. So x minus 4 squared has to equal to 16. Now I just asked myself another mathematical fact. What squared is 16? What number times itself is 16? 4 times 4, 16. Negative 4 times negative 4 is 16. So whatever's behind my pen can be negative 4 or positive 4. So x minus 4 could be negative 4. X minus 4 could be positive 4. And once again, all right, you may know the math fact, but if you don't know the math fact, just get it equal to 0. Well, there's my first one, x equals 0. 0 minus 4 is negative 4. Minus 4 minus 4. X minus 8 is equal to 0, right? X is equal to 8, right? 8 minus 4 is 4. All right, last problem here. Let's end with an exponential here on problem 12. All right, so what divided by negative 32 is positive 2? What divided by negative 32 is positive 2? And that would be negative 64, right? So negative 64 divided by negative 32 is 2. So whatever's behind my hand has to be negative 64. All right, so 4 to the x plus 8 is negative 64. Now, once again, an exponential can never equal to a negative number, right? We're only multiplying positive 4 here in this case, right? So if it's equal to a negative, that means it is a no solution. All right, so that wraps up this particular lesson. All right, have your notes ready. Any questions you have over those problems ready to go, and I will see you in class.